Hi everybody, welcome. Glad to see you all again. Hope you had a fantastic weekend and are ready to keep traveling down this path. Got some great stuff to talk about today. I'm sure you're already aware, but we had another deadline yesterday. So hopefully you got those submitted. If you didn't, please talk to your TAs or talk to me today and let us know what we can do to help you get those done and submitted so that you can stay on track. Because, as you've probably already noticed, we got more coming up this weekend. It doesn't stop. We're just going to keep going. So, please let us know if you need any help getting stuff squared away with Vocarium. I know Vocarium can be finicky, so if you need help, let us know. I think there's not a lot going on. It's just keep on chugging. But does anybody have any questions about the past week's stuff or upcoming due dates and things like that before we hop in to today's material? All right, fantastic. So today, one of the main topics that we have to talk about is exceptions. So let's just start with that. Can somebody give me a definition of exceptions, please, in English? In English, yeah. Go for it.
An exception is a notification that something abnormal is happening.
Perfect. An exception is notification that something abnormal has happened in your code. So it means there's been a problem. Something has gone wrong. And that's just part of life, right? As much as you plan, as much as you prepare, as much as you write your programs with all possibilities in mind, somebody, somewhere, it might even be you, is going to find a way to break it and do something that the program wasn't expecting. So we want to be prepared for those situations. Let's talk a little bit more about what exceptions do within our programs. If my program runs into an exception, what's going to happen? It could crash. Yeah, it could crash, especially if we're not prepared for it, right? If we're not ready for that exception, if we're not even aware or attempting to do anything about it, then that's probably what you're going to see. It's going to crash. As a matter of fact, we've seen this already lots of times, and we're going to see it again lots of times. Programs crash all the time. Your programs are going to crash. My programs are going to crash. That's just part of the deal of being a programmer. And so I think one of the most useful things with exceptions is for trying to explain what the heck happened, what went wrong, right? Try and decipher the exact issue that your program ran into. So with that in mind, what are some examples of some exceptions that you may have seen? We've run into plenty. Divide by zero, that's one, sure. Parse errors. So syntax errors, parse errors, does that count as exceptions? Not really, no. Exceptions are going to happen during runtime, so they would be considered runtime errors. Yeah, exactly. Good. So what other kinds of runtime errors? Type error. So I'm treating something as a string maybe, but it's not. It's an int. Sure. What else we got? Index out of bounds. Yeah. If we're dealing with lists, that's a very common one. We're going to see that happen a lot. We're dealing with lists. I'm sorry? Value error? What's a value error? You remember? I'm sorry? Something's wrong in the equation? Okay. I mean, here's the thing with exceptions, right? I just asked her what a value error was. I'm gonna come clean with you guys. I don't know what a value error is. Like, I'm sure I've seen it before. I'm sure it's happened, but I don't have room for all that stuff in my brain, you know? I got enough stuff going on up there to have to worry about all the different kinds of exceptions. So if you come across a value error or some other kind of error, right, don't be ashamed to look it up. Value error Python. What does it actually mean? Tell me what this means. You know, what is value error Python? And we see we've got a few choices here. And so this is a long page, right? Don't read it. Search for the part that's relevant to you. Maybe that was a bit extreme. I'll walk that statement back. Search for the part that's relevant to you. We're interested in value errors. So, you know, you could even do a Control F and search for value error. It's probably on here somewhere. It is a subclass of, all right, value error. Raised when an operation or function receives an argument that has the right type, but an inappropriate value. So that could be, what? What's an example of that, perhaps?
Like a negative instead of a positive?
Like, I'm expecting a positive value, and you gave me a negative value. That's a value error, right? Exactly, right? So yeah, that's the good thing about exceptions. People I think are afraid of exceptions or frustrated by exceptions when they happen because it means stuff's not working. But actually, it's a good thing. It's giving you information about what's going on in your code, and you can use that information to make your program better. So that's the silver lining with exceptions. Don't be afraid to look them up. You're not going to be the first person that this exception has happened to, and you're not going to be the last. And there's going to be people out there complaining about these exceptions, just like you're complaining about these exceptions. So go find those posts. They'll help you feel better, and they'll help you solve your problem. Please, please, please look these things up when you need to. All right. What is a try except block? What is that for? Let's break it down. What's the try part for? When you have something in normal that pops up, can we?
The normal part of your program, what you want your program to do,
So-
in the try section.
So try literally means the computer's going to give it its best effort, right? It's going to try to do what you want. If everything works smoothly, then the try should hopefully run into no problems, right? But that's not accurate. That's not real life. Sometimes problems happen. And so that's where the except block comes in, right? What's the except block for? So when something pops up, but we actually have a name for that something that pops up. What is that something then? An exception. An exception. The computer science term, we'd say it raises an exception or it throws an exception, right? So it's gonna try to do the stuff in the try block. It really wants to finish it, right? But we're understanding as programmers that sometimes things go wrong. Sometimes exceptions are gonna get raised. And if an exception gets raised inside of that try block, it's going to go to the except block. And then what happens in the except block? What do?
You tell the program what to do when you get an exception.
Yeah, so we tell the program what to do when an exception happens, but what are the options there? What are the things that we might tell the program to try to do? Yeah.
Communicate to the user what the exception is, and like layman terms.
Yeah, so try to give a description of the problem, right? Especially if you're showing this information to somebody who's not a programmer, who you're not expecting to be tech savvy necessarily, right? Show them a message that explains what they did wrong in plain English so that they can fix the problem, ideally, the next time around. What's that?
Your redirections.
Sure, yeah. Something descriptive of what the problem was. We can take that a step farther, right? Sometimes we might be able to actually recover from an exception. Maybe you're trying to use a particular value that didn't work out. So, okay, in the exception, I'll just use a value that I know is going to work. I'm going to tell the user, of course, right? And the value you give me is bad, but I'm just going to use this one instead because I know this one is going to work. And then your program can at least still continue with that default value in its place. That could be something that you do in an except block. But notifying the user is really the important piece there. Tell them what's going on. Tell them what the problem is so that they can try to fix the issue that they ran into. So when should we be using try-catch blocks? That's maybe the most important question that's up here. Now that we know about exceptions, now that we know about try-catch blocks, might be tempting to go sprinkle them in your code. Or it might be tempting to just write a program and then stick the whole program in a try block, right? And then catch all of the exceptions. When should we actually be doing that? Yeah.
Does catch always need try?
Does catch always need try? It sure does, yeah. Or except is the Python word for catching. Yeah. Did I see another hand somewhere? Yeah.
If the accept part of the try except block, if that purpose is to warn a user that they're doing the wrong information, perhaps you would try except blocks every time the program requires user input.
Yeah, so we've been talking about user information a lot, and that's for good reason. It's a very classic case of using try except blocks anytime I have user input. Because who knows what a user's going to type into the computer, right? They could type in anything, literally anything. And sometimes they're going to give you what you want, and sometimes they're not. They're not going to give you what you want. And so using a try except block is a perfect tool for the case when they don't give you what you want. They don't give you something that your program can use properly. So that's not the only time, though. We'll see them actually, we haven't gotten to these kinds of things yet, but we will see them used a lot with things like files. Let's say I write a program that wants to use a file. We do those things all the time. But what happens when that file's not there anymore? Somebody moved it, somebody deleted it, right? We're going to use a try except block to catch that exception if it happens and say, hey, I was looking for this file. What'd you do with it? Where'd it go? Put it back, please. What if I need to get something on the internet? The internet's great when it works. Sometimes it doesn't work. Sometimes your computer's not connected to the internet. Sometimes the internet's down. All kinds of stuff can happen, right? If your program needs the internet, then you might try to do some things that are going to connect to the internet. And then if they're not, the internet's not working for whatever reason, you can use the except block to say, hey, I really need to get online to do my job. And I'm not going to be able to go forward until you let me get online. So they can try to fix it. Those are some just common situations for when you're going to see this kind of behavior pop up. All right, last question, at least on this slide. What is a finally block? What is a finally block? A third option? Sure. It's sort of got a similar feel to something that we talked about last time. Sort of feels like an else. That's right. Sort of feels like an else. There's one big difference, though, between the two.
It'll run every time?
It'll run every time. Every time. The finally always runs. Every single time. Whether there was an exception raised or not, I'm going to do whatever was in that finally block. So what's the big deal? Why do we use those? Anybody know? Yeah, go ahead.
It's when you have something you really want to execute, even if there is an exception thrown, right?
Sure, but so yes, if I really want something to execute, even when an exception is thrown, I guess I was looking for something a little more specific. Anybody know a specific situation when that might come in handy? Closing a file. So I know I'm bringing up a topic that we actually haven't really talked a whole lot about yet, but if I open a file, I have to close the file, right? So whether I successfully was able to make it through the code or not, that file needs to be closed. So a finally block is a great place to do that. That's a classic example of using a finally block in your code.
I don't get it.
I'm sorry?
It executes no matter what. So why doesn't it have this when I have the file closed after the try block?
Why not just do it after the try block? Because if there is an exception thrown, then you may not run after the try block. You may...
But the finally block executed even if there was an exception thrown.
Yes, that's true. So if I don't use a finally block, then the code that comes after the try except block may not execute if there is an exception, right? The finally block means that it's guaranteed to run, whether an exception was thrown or not. Yeah, good questions. Any other questions? So that was one of the main topics today. Yeah, go ahead, question.
Are there situations where finally won't run, like with like a hard crash of some sort?
Situations where finally won't run. That's a good question.
I guess endless loop.
So yeah, if you ever do something, I mean, infinite loops are just sort of in a category on their own.
Yeah.
Could make something like that happen. I think it would be very difficult, actually, to make a finally block not run. I don't want to say impossible, because I don't think anything is impossible when dealing with computers necessarily. These things can happen. It'd be very difficult to run into a situation where a finally block is not going to run. It's a good question, though. Any other questions? So exceptions were one part of today's prep work. The other part of today's prep work was focused around problem solving. And actually, this is such an important topic. It's actually kind of difficult to teach, if I'm being honest. I wish I could teach this topic very well. I wish I could just open up your brains and be like, here's how to solve problems. It doesn't really work like that. It takes practice. It takes a lot of practice to get better at solving problems. So this is an area that's really not necessarily dependent on code so much as just critical thinking skills, which are going to be very valuable to you as a programmer. And so I think the prep work did a very good job of explaining some steps that you can use to take a problem and break it down into some more manageable pieces. And I want to try an exercise like that with you now as a group. So here's what I'm going to do. In a minute or two, I'm going to show you a problem. It's a problem that I'm hoping you haven't seen before, but maybe some of you have. And then what I want you to do, I'm going to put the problem up on the screen for maybe 30 seconds. It's not a very long problem, right? For maybe 30 seconds, I'm going to let you look at it, and then I'm going to take the problem down, and what I want you to do is find a neighbor or two and restate the problem to them. Explain the problem as you understand it in your own words, and then try to break it down. Make an outline for that problem, and then reduce the problem into smaller pieces. And then we're going to actually do that together as a group after I give you a chance to talk about it with your neighbors. Does that sound good? Any questions before we get started? All right, so I'm going to show you a problem. It is a math problem. I know it's late on Monday. Sorry. We're going to do a little bit of math. It's not difficult math, though, I promise. I'm going to show you a problem for about 30 seconds, and then let you talk to your neighbors about it. Let me zoom in on it so you can actually read it. I don't care about the actual numbers. Substitute any numbers that you want in here, right? I'm interested in the actual problem. Taking pictures cheating, I saw that. Few more seconds to think about this problem. The prime factors of a very large number are some smaller numbers. What is the largest prime factor of any number, let's say? Forget about the specific number. I don't care about that number. What's the largest prime factor of any number? All right, I'm going to walk around for 5 or 10 minutes, let you talk about this with your neighbors. Again, remember the goal. Restate the problem. Explain the problem as you understand it to one of your neighbors, and then outline and reduce that problem. Make it a more manageable problem to solve. And we're going to talk about that. Did you have a question?
What's the definition of prime factor?
Prime factor? So, well, talk to your neighbors about that part. I think that would be a good thing to talk to your neighbors about. I'll be around if you have any questions.
So you know what a factor of numbers? Okay, a prime factor is just it's a factor of numbers. The first part of the problem is I know it's generating prime numbers. I actually I'd rather research that. It might be a really good I'm pretty sure it's from it might be a really good program. I'm pretty sure it's yeah, so what we do is we just get a list of all prime numbers, even if you a list of half the ones that are more than half the size, I guess we can check the number itself. It is and then we'll just use the You probably want to build a random table and just, even if you're not online, you can just select actions right the list of prime numbers. Might be a better way.
Alrighty. Let's talk about this problem. I did a few laps while you guys were working on this, and I heard some great conversations. I heard some great questions. So thank you for participating. I really appreciate you putting in the effort. Let's see if we can start tackling this problem. If I'm faced with a problem, the first step, what's the first step? The first thing you're going to try to do? Yeah.
You need a list of prime numbers.
Well, let's take it back even farther than that. What's the first thing I need to do if I'm trying to solve a problem? Restate the problem? I'm going to state what I know. What do I know about this problem? Before I turned you guys loose, somebody asked me what a prime factor was, right? Which I totally understand that maybe you've never thought about prime factors in your entire life. I don't think about it very often. Basically once a year when I do this problem, right? So what is a prime factor? Well, okay, maybe we needed to take a minute and just make sure that we're clear on the terms. This happens all the time. I get asked to solve problems that are in areas that I'm not explicitly familiar with, and the first thing I gotta do is familiarize myself with the actual terms of the problem, the contents of the problem itself. So let's take a minute. I saw some of you Googling prime factors, right? We can break it down. Prime factor. Factor is what? It's an even multiple, right, of a number. So factor is an even multiple of some number, right? And then prime, number only divisible by itself and 1. So a prime factor, right? Prime factor, oops,
Oh, I see.
means I give you a number, you figure out what the factors of that number are, and then of that list of factors, tell me which ones are prime. Right? Question in the back. Even multiples, so a factor of, well, we're talking about integers here, I guess, just to simplify the problem. I don't want to deal with floats necessarily, so if I'm dealing with integers, the factors are going to be integers as well. At least for the sake of this problem, they are.
That's definitional.
Well, I'm defining the problem right now, so that's what I say. We're dealing with integers today. Yes? Oh, well, yes, I meant this as it goes in evenly, not that it's 2, 4, 6, 8. Sorry if that was confusing. Sure. Question?
Yeah, you said we need to figure out what numbers, are what are its factors. Would we not need to find Would we need to find all its factors or just the prime factors?
Well, that's the question, right? I mean, so let's take it one step at a time. Though we have a set of steps that we can use to solve problems, and that's what I'm interested in. So let's follow those steps. We've stated some known things, right? A prime factor is, given a number, which of its factors, and there might only be 1, or there might be 0, right? R prime. So that's the goal that we're looking for. If I give you a number, which of its factors are prime? And the problem actually, gave an example of prime factors. Oh, did I close the window? Shoot. Bail me out, computer. All right, so if we look at these, right, the prime factors of this very large number are 5, 7, 13, and 29. So they're saying that these numbers are all prime and they all evenly fit into this number. I don't know the math behind that. I'm not going to double check it. I'm going to take their word on that. So, now that we've defined our terms, right? Now that we've defined our terms, we can start to try and piece this problem together in a little bit more detail, right? So I'm interested in outlining and reducing this problem. I actually think reducing this problem is going to make it a lot more clear. So what are the smaller pieces that you see that we could tackle in this problem? What are those? Yeah.
Find out if integer is a factor by using modules.
Find out if a number is a factor or not, right? Or actually, so what's the input of this problem? The input is some number. It could be any number, right? I could give you any integer value. So the input to this problem is any integer value, and the output is a list of prime factors, right? So one thing that we need to do is we need to just find out factors. Forget about the prime. I just need to figure out what the factors are of a particular value. So that's one way we could reduce the problem. So what programming tools might we use to solve that? If I want to find out the factors of a number, what programming tools? Yeah. Modulus operators probably in there, right? Anything else? For loop? Anything else? I'm sorry? If else might be in there. Anything else? There's one that I was hoping somebody would say first. Function, yes. Function. All right, let's back up for a second. Let's back up for a second. Make a function to find factors. Make a function to find factors. All right, this sounds good. Right? How do we find factors? You said all those other things, modulus loop. Which one comes next?
Loop.
A loop. Loop through all the numbers from what to what? From 1 to...
You only have to go halfway through, right?
You'd only have to go halfway through. 1 to the input over 2, right? We can stop there. A little shortcut. All right. And then what? What's next? If modulus of loop value and input is 0, we found a factor. If it's not 0, then we don't care. We don't have anything to do. Notice this is an actual code. I'm actually not going to code this up, which might be a little disappointing to you. I want you to code this up eventually, hopefully. I'm writing pseudocode. I'm trying to break this problem down. I'm just trying to approach this from a problem-solving perspective, not a programming perspective. So we're going to make a function to find factors, and that function is going to loop through all the numbers from 1 to the input over 2, and then if I take the modulus of that value in relation to the input and it's 0, that means we found a factor. And so if I do this, I'm going to end up not just with one factor, right, but a whole bunch of factors. I can tack them on a list, you know. So those details I'm not too concerned about at this particular point, if I'm being honest. I'm just trying to rationalize the problem, solve the problem. And then I can worry about more specific details, like how do I write the code? Where do I put this value? Things like that. So, all right, we now have a general way of finding factors. What's the other part of this problem? What's finding primes, finding prime numbers. And so we're going to make a function to find primes. What's the input of this function going to be?
Factors.
Factors? Can we be more general?
Any factor, as well as you have to check if the number itself is prime, because then it would be a prime factor of itself.
So I mean, do I care whether the numbers that I'm checking are factors or not? The function doesn't care. I'm just checking numbers. Where do they come from? I don't know. I found them in a dumpster out back, right? I don't care. I'm just finding prime numbers, regardless of where they came from. I think that's really important to the problem-solving process, right? I'm reducing the problem by breaking it down into its component pieces. I'm not worried about how those pieces are going to interact with each other. I'm not worried about taking this piece and connecting it up to this piece. I'm just saying, all right, here are two subproblems that I'm going to solve. And then once I'm satisfied with the solution of those subproblems, then I can think about how to connect the two together to solve a larger problem. That's problem solving. Find the smaller pieces and then build it back up into a larger solution. So I'm making a function to find primes, right? So it's going to take in a value, and I have to determine whether that value is prime. So what am I going to do? What am I going to start writing here?
We're going to 1 to n divided by 2, or I guess 2 to n.
Oh, so it feels very similar, right?
Yeah, we're just going to modulo every number, and if none of them equal 0, it's prime.
So it feels very similar, right? Prime number is only divisible by 1 and itself. That's the definition of a prime number. We define it up here. Only divisible by 1 and itself. So what I'm going to do is I'm going to try and divide it by all the other numbers that I can. And if I don't find any that work, I know it's prime. I know it's prime. So we're going to loop through all the numbers from what? Where are we going to start?
2. The smallest prime. Or I guess 1.
1?
Or 2.
we have to be careful. 1 goes into every number.
Yeah.
So we don't even need to check it. And it's part of the definition of a prime value. We know it's divisible by 1. Everything is divisible by 1. Anytime I divide something by 1, the remainder is always 0. Doesn't matter. So we're going to start from 2 to what? Where are we going to stop?
To n divided by 2.
Input over 2.
Although you actually want to check the number itself as well. I want to check n as well.
Why?
Because it's a prime. Because if the number itself is a prime is a prime number, it is a prime factor of itself.
Every number is divisible by itself, correct?
Yes.
Do I need to verify that fact?
Yeah. No, you need to check if the number is prime, the first number, because that would technically be its highest prime factor.
I'm not sure that I understand.
I guess if the other function found no factors, then, or I guess that only found one.
The other function found no factors, then we're dealing with what, 0? Or 1 maybe?
That's a good point.
Could be a prime, well, not a big number could be a prime number, you just don't know.
Well, that's a weird thought.
All the numbers from 2 to input over 2. I like this loop as it is. And so we're going to check. I can write another if statement, right? If modulus of the loop value and input is 0. So this time the outcome's a little bit different though, right? If the modulus here is 0, what does that mean?
Not prime.
It's not prime. It's not prime. That's what that means. If I find a number that goes in evenly, it's not a prime number. It's not a prime number. So here, we know it's not prime. When do we know that it is prime?
The exception,
If it has
Has a remainder? So when do I know for a fact that the input value is definitely a prime number? At what point in my code? Do I just say else is prime? Is that right?
I don't know.
So think about this. How many values are we going to check here? 1? A lot, right? We're going to check a lot of values. So what I'm saying is if I find one value that goes in evenly, it's not prime. But if I check one value and it doesn't go in evenly, can I say, all right, it's definitely prime? No.
Oh, else it can keep going.
Else I have to keep going. So back to my original question, when do I know that this value is prime?
Oh, if it runs through the whole loop.
If it gets through the whole loop and I have not proven that it's not a prime value, then I know that it is a prime value. So if I get through the whole loop, right? Made it through the loop, input is prime. Question? So the question was, why do I stop at input over 2? So we're dealing with only integers here, right? So if I use a value that's larger than that, if I think about 10, for example, 10 divided by 6 is never going to be an integer because 6 is too large to ever, and so is 7, and so is 8, and so is 9. I can stop at 5, right? Because I know that 5 goes in twice. And so that's the largest possible value that could evenly go into, largest possible integer value that could evenly go into my input. Or in other words, 2 is the smallest factor that we care about. We don't care about 1, but 2 is the smallest factor that we care about. So if I check 2 as a factor versus whatever the converse is, in this case it would be 5, if we're talking about 10. Right? I don't have to worry about any numbers larger than that because that would put me into fractional territory. I don't know if I explained that well enough. If it bothers you, this is still correct. This will still get you the right answer. But this will save you some time. And so now I've got two functions. I've got one to find factors. I've got one to find primes. Right? One to find factors and one to find primes. So if I want to solve the full problem, then what do I need to do? So we're going to make another function, one more function. Make a function to find prime factors. Okay? And inside of that, we're going to call the function that finds factors, right? Take the output from previous function and call function that finds primes. Sorry, that doesn't all fit on one line, unfortunately. Maybe, no? Okay, whatever. Sure. What did I do? Oh, okay, it will. There we go. And that's it, actually. That's it. We took the problem. This is the problem that we actually wanted to solve, right? We broke it down into two smaller problems. They look very similar to one another, actually. Broke it down into two smaller problems, and then we combined those two smaller pieces together. We actually have a term for that when we combine pieces of our program together. We talked about it last week. Composition. Yeah, we used composition. That's what a reduction is ultimately going to lead to. Reduce the problem into its smaller pieces and then use composition to stick those pieces together to solve a larger problem. If you thought that this was a challenging example, good. I wanted it to be a challenging example because this is hard. This is difficult. This is not easy. It's going to take practice. It's going to take a lot of practice to get used to thinking about problems in this way. I can't do it justice in one class period. I wish I could, but I just can't. At the end of the day, you're going to need to spend some time thinking about problems and solving problems. And so, fortunately, there are some resources you can use to help with that. If you liked this problem, or even if you didn't, there are more where that came from. This is a website that you can go to. It's called Project Euler. I know it doesn't look like the word Euler, but it's a person's name. That's how it's pronounced, Project Euler. And it has a series of problems that you can solve using programming. And once you get the answer, so here they want to use specific numbers, right? They want you to use a specific number. So find the largest prime factor of this value, right? We didn't even talk about how to find the largest one. We didn't even get there. That could have been another reduction, perhaps. And once you, I'm not logged in right now, but once you make an account and sign in, there'll be a box that says, all right, tell me what that number is, and it'll check your answer to see if you got it right or not. This is good practice. I will warn you, all the problems are math-based, so you may need to brush up on your math skills if you're interested in using this website. But it's a great website. And they get harder as they go along. They tell you how many people have solved these problems, and there's a lot of them on here. If you go to the end, the very, very end, yeah, just not a lot. And I'll be honest with you, the math gets really hard, and I'm not even sure that I would be able to understand the math in some of these later problems without sitting down and spending a lot of time thinking about it. So, but I'm not saying you should go home and do all 645. I mean, if you want to, that's up to you. But if you're looking for a little extra practice, you should be able to do all the ones on this first page without any trouble. So that's a lot of practice right there. Solving problems, writing code. So take a peek at this website if you're looking for a little extra practice. Are there any questions that I can answer? Yeah, what's up? With the notes? Yeah, for sure. What's up?
So the second function is a big function find prime. So that's literally going to go 1, 2, 3, 2, all the numbers up to the input there. And it's going to divide every single number by every number before to try to figure out if it's prime.
That's right, yes.
Wouldn't that take a long, if the number's 100 million?
Yeah, it could take a long time.
Would the computer just sit there for a while?
Yeah, it could take a long time, that's true.
Is there a quicker
There is actually a quicker way to do it, but I felt like I was blowing you guys' mind enough. But
I was thinking divide by 2 figure it's an even number, divide again, so you get the 2.
there is a quicker way to do it. I hesitate to go too much into the math here, but actually what you can do instead of the input over 2 is the square root of the input instead. So that cuts down the range even more. Makes it a lot faster. Could still be a lot, especially if I give you a very large number, right? But still, those kinds of shortcuts.
Two twos as well. It's 2, 2, 2.
Oh.
2, 2, 2. Just typo.
Yeah, sorry. But I mean, those little shortcuts make a big difference. Make a big difference. So that's a great observation, though, and something that you should definitely be thinking about. Writing a program that works is no good if it's going to take you the rest of your life to get the answer. That's just a fact.
When we're trying to figure something like this out, is it cheating to go to Google and find the formula and put the formula?
Is it cheating?
Is it not doing what we're supposed to do?
Well, I mean, if we're asking you to do something in class, I would say, yeah, that's cheating. If you're doing the problems on Project Euler, nobody's gonna bust you for cheating, and you actually can find the.
If I found, just for the sake, just to work this out, the second function, I found a formula that works to find the prime number.
Yeah.
Well, let's say Python is a built-in function.
Okay.
Would be importing the math module.
And I believe that actually is a thing, actually, in the math module that you could use to find prime numbers. Sure.
I looked that up on Google and used that. Am I cheating myself?
You get out what you put into it. That's what I think. If your goal is practice, then you should be writing code. If your goal is deeper understanding of how to write programs and solve problems, then you should be writing code and solving problems. I mean, I'll be honest with you. I don't write this function. If I need to use it, I use a function that already exists. That's true. But I have written this function plenty of times. I wrote it when I was in school, and now I write it with students all the time. It's a great learning exercise. So you get out what you put in. Any other questions? Yeah.
No, we didn't cover this, or maybe I'll find you can go into it. Would this also be a good candidate for recursion?
For recursion, sure. Yeah, there is a chapter in the book about recursion if you're interested. I think some of you may have stumbled upon recursion, either yourselves or through a TA. But finding factors is a recursive problem. Finding primes, I guess you could solve recursively. I'm not sure that it adds anything necessarily. This is a classic recursive problem, though, finding factors of a number. Yep. And in general, I mean, anywhere you see a loop being used, iteration, you can replace it with recursion. Now, should you do that? The answer is almost always no, but you can. You can. Any other questions? I do have a walkthrough, but I'm happy to take more questions if you have questions. The walkthrough is another problem-solving exercise. It's actually not quite as challenging as this one, but we haven't written any code yet today, and I'd like to write some code. So let's do that for the last chunk of time that we have. Let's go back here. And so we've got a problem description. It's a bit of a simpler problem than the one that I just showed you. What we're looking for, we're going to write a function that takes a list of integers and then a string. That string is either going to say positive or negative. And so what we want to do is, if it says positive, we're going to look at all the numbers in the list and print out the positive values. If that string says negative, we're going to look at all the numbers in the list and print out the negative values. Okay? This is another problem that's a very good candidate for reduction. In fact, they already provided the reduction for us, and so it's just left to us to actually code it up and tie the pieces together, which is what we're going to do for the remaining time today. So the first reduction that they present to us is to write a function that takes an integer and prints out positive if it's positive and negative if it's negative and nothing if it's 0. Seems simple enough, right? So let's do that. I'm going to make a function. What should I call it? Print sign, I guess. And the input is going to be an integer. We'll call it value. Okay, and then how am I going to do this? I need to check this value and see if it's positive or negative. So what am I going to use to pull that off? Modulus? I can just use an if statement, say value greater than 0. All right. Then I want to do what? Print positive. All right, what's next? Else. Is it else or else if? Because it could be 0, right? Think about that. The question that I really asked you when I said is it else or else if, I'm really asking you how many different possible options are there, right? If I use else, I'm saying there are 2 possible things that could happen. But you're telling me it's else if, which means there's not 2, there's at least 3 possible things that can happen with this, which is true. We don't want to do anything, but that's still 3 not doing anything is still a path. Yeah, it's still a path. So by using else if here, we're saying that there's 3 possible things that can happen. So what are we looking for? We could say, I mean, we could do either one, right? I could say equals 0 here, or I could say less than 0 here. It really doesn't matter. I could get there either way. I think it's a slightly faster to do it this way, just slightly. All right, and then else what? All right, else nothing. We're good. We're good, right? If it's 0, I don't need to do anything, so I don't need anything else. I'm just going to leave it off. So we have a solution, and before we proceed, we should test it. We should test it out. So let's say print sign, oops, and give it a number. 3. 3 is positive. I hope it tells me that it's positive. -3 is obviously negative. And then 0 is 0. It works. That's one piece. Okay. Level 2 says write a function that takes a list of integers and only prints the positive ones. Only prints the positive ones. Okay. Print positive. List. So we're dealing with a list this time. List of ints. All right. So now I have a list of values and I want to print the positive ones. What's first? I need a loop. I need a loop to do this. For I in range? Question mark? Let's do this. List of ints. Good. All right. What do I need to do next? I'm going to check to see if I is greater than 0, and if it is, oops, I accidentally a thing. And if it is, what does it want me to do? I don't even remember. Print it out. Oh, okay, that's easy. Print I. Okay. That's it. We think we're good, right? If it's less than 0, what do we want to do? Nothing. We're good. Nothing. All right. Let's test it. I need to make a list. So list. How do I make a list? Brackets. I need some positive and some negative values. And 0 too. Why not? I don't know. It's positive. And then I need to use my print positive on L. All right, so if it works, I should get 5, 9, and a bunch of 8s. Let's see. 5, 9, a bunch of 8s. Okay. So what we've done is we've taken the concept that we played around with in the previous part and we've expanded on it a little bit. Now we're not just checking a single value to see if it's positive or negative. We're checking a whole bunch of them. And so part 3, we're going to put it all together. Takes a list of integers along with the string. So we're solving the problem now. We're solving the whole thing. The string's either going to say positive or negative, and then what we're going to do is print out the the integers that are requested. Okay? We're going to say print ints. I don't know. So the inputs are a list of ints, and a sign. Okay, what's first? What do I do first? I heard if what? If sign equals,
Or
double equals, no, you're fine. Equals, what do we want to do first? Positive? Doesn't matter. We can do either positive or negative first. If sign is positive, then what do we want to do? We want to go through the list and print out the positive ones. Well, wait a second, we did that. That's what this is, right? All right. Oh, I just cheated. I'm just kidding. That's not cheating. Copy paste is your friend. No, I'm serious. Copy pasting is a perfectly valid way of saving yourself some time. Please copy paste code, but there's always times when copy pasting is not bad, right? Too much of a good thing. Bad is bad. If you find yourself copy pasting stuff all over the place, probably one of two things is happening. Either you're not writing any code at all, right? Or you are, you should be using functions instead of copy pasting the same chunk of stuff every time you want to use it. But in this case, it's totally acceptable. All right? So there's the positives, and then I want to do the negatives, right? So what do I do? Elif sign equals negative. And then we're going to do the same thing again, right? Boom. There we go. Bet you guys didn't know that coding had sound effects. I just flipped the sign. I just flipped it to say less than instead of greater than. Does it bother you that this looks a little repetitive? I mean, it's fine. I think it's going to work, actually. I mean, we can try it out real quick and see, and just make sure that it works. Maybe I should make sure that it works before I start criticizing it. Positive. Print out all the positives. It should give us the same answer as before. 5, 9, and a bunch of 8s. But if I switch it to negative, then I should get the negative values. -4, -2, and -1. -4, -2, -1. So it seems to be working, but you know, back to the question that I just asked, like, does it bother you to do it this way? Is there a different way we could have done it? Can I call some functions? Maybe. Maybe. I mean, here, definitely, right? Here, definitely. Print positive. List of ints. That would definitely work. But down here, I don't have a print negative. I can make one. It would look very similar to this, would it not? And so then how is that any different than what I had up here before? It's just two loops. They're just in a slightly different place now. Is that better? Is that worse? Yes. It could be better. It could be worse, depending on what my ultimate goal is. There's other ways we could do it too. There's other things that we could do to approach this problem. For example, what if I didn't want to start with the if statement, but I wanted to start with the loop? Could I do that? Yeah, sure. I could. How's that going to change everything else? I want to put an if here. What does my if need to say? If sign what? If sign equals positive, what else? It's a little tricky. And and I is greater than 0, right? That's one case that I want. That's not, so I'm going to wrap this in parentheses because those two go together, right? Those two things go together. If the sign is positive and I is greater than 0, that's one possible value that I want to print out. What's the other situation? So then I could say sign, I could do a separate if statement here, right, if I wanted to, and just do the other one. Or I could put it all in one big giant if statement if I wanted to. I could say sign equals negative and I is less than 0. What am I missing? In between, I need an or, right? If the sign is positive and I is greater than 0, or if the sign is negative and I is less than 0, what do I want to do? Print I. Is this better than the solution we had before? I don't know. I don't know either. I don't know. It's different. It's a different way of doing it. What did we trade off? We traded off having two loops that looked very similar for having one giant if statement.
Does it work?
Does it work? Good question. Let's try it out. Always a good question. Does it work? The negatives work. Let's try the positives. Positives also work? Yeah, it works. It seems to. At least for the numbers that we have with us. Yes, it seems to work. So in that sense, right? In fact, we have a name for that in computer science. We do that so frequently that we have a name for it. If I have a function that works, and I come in and I rewrite it with the goal of making it shorter or more clear what's happening, we call that refactoring. The goal is not to change the behavior, right? I want it to work exactly the same as it did when I started. Exactly the same. I'm just rewriting the code to make it look a little better. That's called refactoring. Something that we do quite frequently. Because maybe you guys have already noticed this, right? When you first solve a problem, your goal is what? Get the damn thing to work. Just get it to work. I don't care what you got to do, right? I don't care, you know, you're just banging out all kinds of code, and maybe it looks great, and maybe it looks hideous. I speaking from my own experience, it often looks hideous. So I'm just trying to get it to work. I write some very nasty looking code. Might have like blood smear all over my screen or whatever, you know. And then I'm going to go back and I'm going to clean it up. Okay, I know that it works now. I've solved the problem. Let's go back. Let's make it look a little nicer. So that when I have to show this to my boss, right? He's not gonna wonder what the heck's wrong with me. He's gonna think that everything's okay. Or your coworkers or whoever else is gonna look at it. Or even you 2 weeks later, right? That might be the most important. You don't want to come back to your code and be like, oh man, this thing was a mess when I wrote it and it still is, and now I don't even remember what I did. Make it look a little nicer. It's called refactoring. Anyway, I think the solution works. Are there any questions? Yeah, in the back.
So, most of the examples we've seen in the textbook, when defining a function, uses the return statement.
Okay.
And then I think it was this example, maybe an example before that utilized a print statement
Sure.
instead of a return statement.
Yeah.
Defining a function. When do you use one of those?
Yeah, all right. Great question. So the question was, a lot of functions that we've seen in the book use return statements. And in this particular example, and maybe some of the other ones in the book, I'm not sure, we're not using return at all. We're just printing the answer, right? So when do we return versus when do we print? It's a great question. Does anybody know the answer?
I mean, I know the question is like explicitly asking for print.
Yes, yeah. But in general, yeah. In general, there is a general answer. Does anybody know? Yeah.
Sometimes you don't want to print it, you just want to return it so it can be used by something else.
Does it have to be used by something else? Does the answer that I'm computing right now, the value that I'm computing right now, does it ever have to be used in another part of my program? Does it have to be used by something else? If the answer is yes, what should I do? Return. If the answer is no, I can print it out, right? I'm printing these values out. I can't touch them again after that, right? I don't have this list of positive values to work with. I just printed them out. There is no list of positive values. It's just on the screen. So if your only goal is to notify somebody that something's happening or yourself that something's happening, then printing is perfectly fine. But if you're expecting to use that information elsewhere, returning is the way to go. And actually returning, you can actually do both, right? If I return a value, I can still print it later too. So in that sense, returning is a bit more flexible. Great question. Can you have a print and a return? Sure. Which one would I do first? Print. Got to do the print first because return ends it. Ends the function. So if you're going to do both, which you certainly can do the print first, then the return. Great questions. Any other questions? Print and the return? Yeah. That's right. Any other questions? So there is a studio today. This is a little bit of a different studio. We actually gave you some code, and we told you how we wanted it to work, but it doesn't work. So we want you to fix it. One thing that we didn't talk about today that was also part of the chapter, very important, is debugging. So I'd love to see you walking this code through the debugger to try and figure out what the heck's wrong with it. I'm planning to go over a solution at 8 o'clock, like I usually do. So you've got over an hour, almost an hour and a half to take a look at the studio. If you wrap that up, you can start on prep work for Thursday or homework assignments or whatever it is that you need to catch up on. But thank you so much for participating today, and I'll see you all at 8 o'clock.